Welcome to the IP showcase video about MNMS, Media Network Monitoring Service. I'm Nicolas Sturmel and I'm working for emerging technologies. My task at the company is to make the use of network easier and with a better user experience. So the base problem is here. We come from a baseband world where it was easy to trace a signal from A to B. You just had to follow the cable from device A to device B. Eventually, you would have a mixing matrix, but this would be very specific, and the matrix would be easy to read as linking an input to an output. Since we switched to IP, the problem has been more complex with many layers of abstraction. You have the Ethernet link, then you have the IP link, then you have the services and the resources that are exposed on the network, meaning that you do not know when you look at the network connections, you do not know where your signal is going, where it is coming from. Nor do you have any information on the quality of this. So this is problematic, and this has been solved in many ways. I have personally spent a lot of hours programming the NMOS software that is used to do some AS67 connection between devices. We can also write a lot of other software, mainly StageNet, for instance, or Home from Ravo. But it's always the same. Where are my devices plugged in? And what is the IP addresses of my device? What service are they presenting? This is the basic question that you ask yourself when you want to operate your network. And of course, the go-to solution is just a sheet of paper and a pen. You note on the sheet of paper the addresses of the device you care and the port number of the different services they expose. But unfortunately, those IP addresses can change. And if you look at how the device is plugged to the network, it can change as well. So what can we do? Well, we can go into a more dynamic system. A more dynamic system that does live documentation. We all know how it goes with documentation. When you try to document a system, it works well at the beginning, and then the system lives and evolves. And at some point, there's no point in using the documentation because nobody ever took the care of evolving this documentation. So for that, we need device discovery and resource discovery. And hopefully, there is a variety of protocols to do that. First, we have the IT protocols. There's the IT standards, like SNMP. SNMP is kind of a jungle, but you can have a core of SNMP parameters that are exposed on most of the switches. And you have LLDP, which is a requirement for the Tier 101 specification, and more and more used into server data center and IT infrastructures. LLDP is for Link Layer Discovery Protocol, so it allows you to discover the device that is connected directly to another one. So you can go on your switch, and the switch can list all the devices that it is connected to, the port on the local switch, and the port on the distant device, etc. You can also do discovery using video and audio-related standards, so NMOS, and mainly the ISO4, MDNS for multicast DNS, if you are mostly on the same layer 2 segment, and SAP, also on the same layer 2 segment, SNMP for Stream Announcement Protocol. SAP is used on AES-67, for instance, as is MDNS. And of course, you have some proprietary control and discovery. You have specific APIs via HTTP or even worse, via Telnet or SSH. And you also have home discoveries that can be done using multicast and broadcast. For instance, Dante is using some multicast addresses to do resource discovery on the network. So the question is, why would I want to go dynamic? Why would even an engineer work on a dynamic system? Agree, the dynamic system is more programs and is prone to more errors. And even if most of the broadcast controllers feel like they are dynamic, they always rely on a static configuration to start with. So if you want to change anything on most of the broadcast controller, you have to actually tell the system what you changed. So again, we come back to the fact of the problem of keeping the information up to date to service the documentation. But IT-based infrastructure, they always change. And they will change, and you will have to quarantine some devices, you will have to change some ports, you will have to change some cables, you will have to delegate the plugging of some devices to someone that will most likely plug them on the wrong port. We all experienced these kind of problems, and I believe that in the long term, the agility of automatic documentation, so knowing where the devices are, what they can provide on the network, will lead to time and cost saving in operations. So this is why I built MNMS for media network monitoring services. And I did it during the first waves of the pandemic, mainly to do remote work and be able to administrate my network without having a lot of pen and paper. So just a word on the architecture. So it's a microservice-based architecture. So you will have the network, and on MNMS you will have microservices. For instance, here we have 2 doing discoveries. We have 2 doing switches communication, and they all go into a big database through a data merger. So it's a simple data mining software with merging rules, and of course those merging rules are the core of the device of the software in being able to cleverly show the interface to the user. But the key value, in my sense, of MNMS is this mission control view. Mission control as in you want to be able to map the system and to have some ballistics and measure, but you don't want to have everything. You want to have a synthetic view of the system, a synthetic view of the ballistics. You want the system to show you the alarms, and the alarms in the order of importance. You want to access to detailed information, but only on demand and not necessarily always under your eyes. So see it as as your cockpit in trying to fly through all these bugs and problems and issues of handling and operating an IT media. So this is the interface of MNMS. You will have first the map of the system, which shows you the switches and the devices and how they are plugged together. Here you can see the Montone devices that I have on my system, which is dual, just 2 legs, one on each switch. The root switch, which is the spine of the system, and the leaf switch 252. You also have the components ordered by priority. So those are all the components shown within the system. You can see that we first have the switches, and they are ordered in a layer in an order of priority that is put inside the system and that is user defined. And then we have the detail view, and the detail view gives you details on what you selected. So here I selected a switch. You can see here that it is selected. So I have the IP address that I discovered. I have the services that were discovered. So the IP, the internet HTTP server service, the telnet service. I have some ballistics on health monitoring, and some details on the ports. So the ports that are connected, their bitrate in and out, and within brackets here, we have also the number of multicast addresses that the port is registered to. So right now, MNMS is compatible with SNMP, although you will not have multicast monitoring when you do SNMP, and I will show you multicast monitoring in a moment. Also, when it comes to switches, you can MNMS has been developed around ad hoc integration of switches, the Artel Quaras, the Cisco SB, SG, and the Arista. Arista is still in beta. We also have the Discovery, which is using LADP and NMOS in beta as well, and also ad hoc discovery. Those two are mainly for the audio networks, MDNS, and the Dante and Ravenna discovery. So now a live demo of the system. So here you can see we first have the view, the list of the switches. For each switch, we have an indicator on the last refresh of the data of the switch. We can see that we have two double attached devices. When you click on the corner, you have text, and you can launch switch services by hand, or you can also have detailed information on the nodes if you want to do some debugging. The switches are shown first, then you can have all the devices that were found on network. And for each switch, you have all the ports on the switch and their status and even their VLAN. So the color around the port is the VLAN that is currently associated as untagged to the port, and you can select other VLANs. You see here, using a dashed line, those are tagged VLANs, so it basically shows that these links are trunks. When you click on the switch, you have the detailed information on this switch. With bandwidth. You can also select a audio device, and you can have the information on the audio device. For instance, here we selected the A line from Ravo, and we have the different streams, and note these streams here. This stream JHJHT, which we'll be using later. We also note if the stream is redundant. So for instance, here we selected one stream, an AES67 stream, so single stream, and we see that it goes up to the spine switch within the system. A bit later, we will go to the Montone. So here we click on the link to show a new web page, the web page on the Montone. And on the Montone, we will try to mess with the system by adding much more streams and trying to raise an alarm on the system. The alarm on the bandwidth is for 500 megabytes at the moment. We will also connect to the A-line stream JHT that I showed you before, and we will be able to show you the different multicast tracing that are available on the system. So back to the system, we can see that ports are now in red and that the switch order has changed. So the first switch, the switch with 2 alarms, is shown first. It's 252. We can see that port 2, which is the port linked to the Montone, and port 9, which is the uplink port, are in red, as is the port 7 on the spine switch, which is the port linked to the 252. We also then can click on the JHT here, and by doing so, we can see that we have those 2 legs that are lit, and those 2 legs are using different colors. So you can see that the first leg is going through the green switch here, and the second leg is going, well, actually through the green switch and the leaf switch, while the second leg is going to switch to 04 through the spine back to the Montone. So this is useful because you can do troubleshooting and debugging, and it gets you an entry into important data. So for as this troubleshooting is concerned, the different user experience are very heterogeneous, and you have much too much data that is displayed usually. So the goal of MNMS is to be a gateway to those software of control and debugging, and to be able to configure them automatically so that with one click can actually show your probe on the network with the proper parameters that you are actually interested to, instead of needing to configure your probe with the actual data that you were looking in MNMS. As for the latest release, we can now see that PTP background 2 has been released, and this would be a perfect candidate with its REST service integration to be called by MNMS with a focus on the information, specific information that you are looking for. So the roadmap. So this is an open source project that you can reach through the this GitHub page. Open source and free, of course. And the roadmap is more support of switches, more integration of debugging tools, and more support of media probing and network probing. So this is on the feature side. On the distribution side, work has to be done in trying to distribute it more easily and to be able to install the whole switch of services, the whole suite of services more easily. Right. Thank you for your attention, and please send me questions via emails or comment or whatever.